Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions, and we'll try to get to as many as we can near the end of today's webinar. Also, at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, we'll go ahead and kick off today's webinar, which is Dependency Health, Removing the Barriers to Keeping Projects in Shape. Our speakers today are Rhys Arkins, who is Director of Product Management at WhiteSource, and David Habusha, who is VP of Product at WhiteSource. Gentlemen, thank you so much for joining me. Rhys, I know you are going to get everything kicked off, so I'll put myself on mute and let you get right to it.
Thanks for the introduction. I'm Rhys Arkins.
I'm David Habusha, VP of Product with WhiteSource, and Rhys, realizing this is our first webinar together.
Yeah, it is indeed. Let's make it a good one.
Let's have fun, yeah.
All right, so today we're going to talk about dependency health and removing the barriers to keeping projects in shape. So we're using the analogy of health here, like literal health, because we thought it's a good way for understanding dependencies, open source, and vulnerabilities. And one of the key things that pretty much everyone should understand is that when it comes to your physical health, it is easier said easier said than done. Everybody knows it's important to be healthy. We know what that means. Most people know what it takes to be healthy. You know, eat healthy food, exercise. But the reality is most people aren't actually truly healthy. And so we thought this was a good analogy for dependencies and what we're trying to do at WhiteSource, because we realize it's more than just knowledge, it's more than just tools, that the reality is people need to follow through. So if we look at dependency health as the analogy, most developers today do know that it's best to be up to date and vulnerability free. Now, rewind a few years ago, and there wasn't such an awareness from developers about keeping dependencies up to date, about vulnerabilities. It was a little bit of a Wild West, but these days, definitely the awareness is there. And I would say that the majority of developers, they do know approximately how to do that. I mean, keeping things up to date and looking for vulnerabilities, depending on which package manager you use. Yet very few projects today are up to date and vulnerability free. So this is very similar to actual health.
So Rhys, you know, this is a very good analogy. You know, I went back to gym like 3 years ago, and it was so hard to get back and restart. You know, there's always those excuses of I'm not in shape, it's gonna take me a while till I get in shape. And once you realize, you know, when you start doing it, that you already have the habit and the procedure of going there and keeping in shape, that's much easier. But usually, you know, just beginning and changing the mindset of I can do it and I can keep in shape, I can keep doing exercises. That's the key to a successful workouts and being in shape in a gym. So I see that analogy very similar.
Yeah, it's funny. I only know you as someone who works out and goes to the gym, but it's a good point though, because I think getting started is hard, and the mental part of it as well. And it's not exaggerating to say that this really does apply to some areas of technology as well, especially when a problem seems very hard to solve or very big to solve in the first place. All right, so just to use some statistics early on, we took a look at a couple of JavaScript packages. One's called ESLint and the other is called React. And we took a look at projects who use WhiteSourceRenovate and that had received a commit within the last 2 weeks. So this is a pretty recently updated projects. And for ESLint, what we found was that barely over 40% were on the latest version. And even if you count latest version or the current major, it's still less than 60% were on the latest major version. Whereas if we look at React, a very impressive 76% were on the latest version. And in fact, React hasn't had a major update in a few years, so pretty much everybody is on the latest major version. And this actually does make a lot of sense. Make a lot of sense though, because ESLint is a library that is used for testing. It doesn't impact your final production product in a way that could cause bugs or vulnerabilities. And it makes a lot of sense why people may not feel the need to keep that one as up to date. React, though, is a much different story. If you're using React, then almost certainly it's on your website. And what that means is that if there is a user-facing bug, or worse, there is a vulnerability, it means you're going to need to patch that like immediately. So to fall too far behind in a public-facing dependency like React would be a pretty big problem. We're going to talk about what it means to fall behind, why being behind in the first place makes it a lot harder, and of course, what companies and projects can do to get ahead in the first place. All right, so David, you have a stat here as well.
Yeah, and this is pretty amazing, and it hits our customers when we first install WhiteSource. So they usually run it on typically very few projects, and they discover that most of these projects have a high severity vulnerability associated with one of their open source dependencies in those projects. Now, it's not just at least one, but many of those projects, they have dozens or hundreds of critical vulnerabilities, and they just don't know where to get started with that. It's kind of overwhelming at the beginning.
Yeah, so even users and companies who have WhiteSource, which is the leading SEA tool themselves, still that doesn't mean that the problem is solved right away.
Oh yeah, that's correct. You always have to keep up and watching your projects, because the nature of open source is that a new vulnerability may come up at every point in time, and you have to keep up on it.
Okay, let's keep going then. David?
Yeah, so again, to the analogy of coaches and trainers, and I had a personal trainer for a while, so that gives you a lot of push on the mental side of stuff. But yeah, I mean, most don't have or don't claim to have kind of magic way of working out. Usually, it's personalized, and there's no one way of doing it, but you have to find the way that would match your skills and your capabilities. But I think that the most valuable contribution is determining what's preventing you from being healthy today. And when you figure that out, it's easy at least to get started. And again, when you get started with it and you feel so good, you always want to stay in shape. So that's the easier part.
Right. So there's no secret ingredients, no secret foods, there's no secret machines. People generally know what it is. It's just a matter of getting started.
Yeah, it's a lot of hard work at the beginning, no doubt, but it's worth it.
All right. So David, you've been working in SEA for longer than most people. Let's talk through what we're calling first generation or current generation of software composition analysis?
Yeah, I would say that first generation was more about scanning code periodically, usually not really fitting into the modern software development lifecycle. But that was probably 7, 8 years ago when most organizations still didn't figure out how to use open source widely or be aware of the risks associated with using open source. So it was mostly about, forensic scanning of projects just to understand your inventory, what type of open source components are being used, mostly for licensing purposes. That's how SCA started. Then, followed vulnerability matching and so on. And then figuring out how to accurately match those components to the right license and the corresponding open source vulnerabilities, taking data from multiple different sources, having the match as quick as possible using technologies as hashing and so on. And when you have that inventory in place, you want to start and apply some business logic, generating licensing reports for audits or for M&A purposes, or together with your release, applying workflows on top of those inventories, for approval of certain types of licenses or medium or low severity vulnerabilities. So that's how the whole thing started. I would say that the notion of involving developers and shifting left was not really present at the time, but that's how the whole industry of SCA started.
Okay. All right. So what's the next generation going to look like?
Next generation is all about automation, leveraging developers and shifting left detection and remediation efforts. The idea is that there's too many open source components being used, and the number is just growing. And we're talking today about close to 90% of the lines of code of every modern app that consists of open source components. And being able to monitor that continuously during your SDLC, understand every change that happens in your code, analyze that change, alert on deviations from your policies with regards to licensing, detecting vulnerabilities, and doing all that in an automated fashion so developers can be on top of everything as soon as they can. And that's, the way open source is being consumed is by using dependencies, by declaring that you want to be using an open source package as a dependency, and you want to automate all that. So, automatically scan, automatically identify, automatically remediate, and so on. That's the whole concept of the next generation of SCA.
Yeah, you mentioned how, around 90% of code in a project is open source. So it can depend a little on how you position it, right? I mean, if you position it like, it takes a lot of work to be compliant with open source, then it can feel like a bad thing. But on the other hand, if someone is going to give you 90% of your software, without charging a payment, then spending a little bit of time making sure that you don't have license or vulnerability problems seems like a pretty good trade-off. But we don't want it just to be a trade-off, though. As we said, we want to put it on easy mode, right? So we want to focus on how to make it an even better trade-off with open source management. So if we look at the dependency management challenge, so use of open source inevitably leads to frequent but unpredictable need to update known vulnerabilities. So, things that are sure in life, death, and taxes. Well, if you use open source, there will be vulnerabilities in something that you use eventually. It may even be frequently, depending on how much you use and what you use. Now, these vulnerabilities, they'll often be a very high priority if there is any possibility that they could be exploited in production. So we talked earlier about reaccess. So like if there is the ability of a production component to be exploited, and typically it might be more your back-end components rather than front-end, but if there is a possibility, then it'll be a very high priority, very high urgency that it needs to be, either removed or updated. So therefore, the more out of date your dependency is, the higher the risk of updating it, right? So you have open source, you're going to need to update it. The longer it's been since you last updated it, the harder it's going to be. And the problem is that you're going to be in a big rush because, you know, it's a high or critical severity vulnerability. So thought of the day here, when we talk about dependencies and vulnerabilities. Now, something that a lot of people don't know is that nearly all vulnerabilities have a fix available at the time of disclosure. The figure, according to our own study for the last year, was around 85% have a fix already at the time of disclosure. So what that means is that, you know, you as a user, you probably, like, you're going to hear about it after it's been disclosed, after it's been made public, which is after there is a fix available. So basically, if you're hearing about it, there's a very high chance that there is actually a fix. And the way fixes are applied to most open source is that they're nearly always applied to the latest release. So it's a new release on top of the newest release. And only sometimes do you find it backported to older, minor or major releases. And this is largely because it's open source, and people developing open source, you know, aren't going to maintain support for 10 releases back or something like that. So they will add the fix to the latest. Well, what does this ultimately mean? It actually means that if you just had the most simple approach where you adopt the latest version of dependencies immediately, you would actually resolve the majority of vulnerabilities. So, you know, it seems like a lot of work, but, you know, one approach could be just always take the latest, and you're essentially automatically remediating all of the vulnerabilities, or 85% of them immediately. However, it's not quite so simple. So let's look at why updating is perceived to be complicated, because there is a good reason why people don't just take the latest version of software dependencies right away. So changes in behavior of libraries can result in a wrong behavior in your application. So that change could come from a major update. This is the easiest, right? Because this is like, it's an intentionally breaking change. If it's in a major release, it's most likely documented and clearly indicated. So you're warned in advance that something is changing and you can evaluate it. Non-major releases but documented is the next level. They're a lot rarer, but this is where a library makes a behavior change. For some reason, they don't want to make a major release, so they document it in a minor or patch release. This is already getting much more risky because if it's a non-major release, you may assume incorrectly that it's not going to make any breaking changes. And then the worst type of, you know, breaking update is the undocumented one. And this is often where the behavior change was unintentional. Like, it wasn't, the author of the library didn't mean for it to change its behavior in a way that would affect anybody, and didn't realize it would be breaking. So these are all the scenarios that can result in a problem if you take the latest version of something and it's actually changed its behavior. And like, additionally, you know, you also might need to retest your application and your services. You yourself may need to issue a new release if the behavior has changed or there's been a feature added. And both of these, you know, testing and releasing, they're more difficult for organizations without a mature, you know, DevOps organization with continuous integration and continuous deployment. So then the reality check to the thought of the day is that adopting every latest release is not feasible in production. So unfortunately, just taking the latest, it is going to cause you problems, potentially a lot more problems even than the vulnerabilities in the first place. However, due to vulnerabilities, sometimes we do need to adopt the very latest release for our own protection. So as a general rule, we don't want to adopt the latest release immediately, but we may need to because of vulnerabilities. All right,
let me jump in.
Back to you here.
Yeah, let me jump in for a second. I mean, let's take the analogy of finding a vulnerability in your own code. I mean, if you had a high severity vulnerability in your own code, would you care fixing it and re-releasing your software? I assume the answer is yes.
Yeah.
So the fact that it comes from a third-party, you know, open source contributor or project doesn't mean that you don't have to follow the same guidelines. It's just, piece of your software. You have to look at it as a piece of your software, and you have to adopt the same kind of processes. So, I mean, although
That's
there's a lot of differences between open source and your own code, when it comes to fixing security issues, you should kind of try to adopt the same procedures.
Yeah, I'd say vulnerabilities in open source can be even more problematic in many cases because, if you find you made a big error in your own code, maybe no one else even noticed, including your colleagues. But if there is a vulnerability in open source code, it means that it's public, and the bad guys can know. So you don't necessarily have a choice as to whether to wait or not. So
Yeah,
then
and
let's
then
talk now
and then start.
about the two big challenges that we've identified in having dependency health, and the solutions that we have released and are releasing at WhiteSource in order to address those.
Yeah, so as I mentioned in the beginning, it's just overwhelming to scan your project for the first time, because you think that you have very few vulnerabilities. You look at the shallow ones associated with your immediate direct dependencies, but most often when you really break it down into everything open source you're using, including all the transitive dependencies or your loose files and so on, um, I, I, I'm seeing that, with hundreds of customers running our software for the first time, that they have hundreds of vulnerabilities. Most of them are between medium to high to critical that they need to actually address. So that's a huge problem to solve, and you can't always see the forest from the trees. I mean, those people just don't know how to get started. What do they need to do first? Um,
Right. So this is similar to talking about the gym earlier, right? All right. So solution one.
yeah. First of all, you want to reduce the number and the quantity of high level or high severity vulnerabilities that you can actually remediate ASAP. That's the first challenge. I mean, how do you prioritize what to do first and what to look at first? So yeah, you can start looking at severities. That's a good start. You can start looking at you know your business applications, what impacts your front end applications, those that are internet facing, that are more vulnerable than your internal systems, and you probably reduced it to a little smaller number, but still you have too many vulnerabilities to look at from the get-go. And the old days of employing security analysts, looking at those vulnerabilities, trying to analyze what to do first is just, it doesn't work anymore. It's not scalable. You have to hire as many security analysts as your developers to do that, or you have to take your developers' time to do those investigations, and both are not cost effective, and not only that, they're not even scalable. So, prioritizing based on severity, yeah, it's good. It's a good start, but it's not enough. And it's like when you get fit, you always delay the start because you think that it's gonna be very hard to start, and you may be a little too fat, or you may be a little too not in shape, and you don't want to give up on your free time to go and to the gym and work out. But again, once you start doing that, you see that it's not so bad, and when you get in shape, when you see the results, um, then that's where you start gaining from doing that.
All right. So the solution here.
So the solution here relies in the fact that first you can automate this analysis, so you don't have to employ a large number of security analysts. You can run automated tools that will tell you if a vulnerability is actually effective. So what it means is that when an open source vulnerability gets published, usually it will be attached to an open source package, like Rhys mentioned, ESLint, React. It could be Apache Struts or Spring that you may be using. But the fact that you're using a certain open source component and there's a vulnerability associated with it doesn't mean that your specific application is vulnerable. at the end of the day, a vulnerability comes down to one function or a few lines of code that denote the vulnerability. And there's only very few ways to run this code or call this code. And what usually security analysts will do, they will try to see if your application actually consumes or runs the vulnerable lines of code or functions. But automated solutions that employ effective usage analysis technologies can tell you that automatically by running a proper scan and reducing the number of vulnerabilities by more than 80%. So, and you can start seeing the forest from the trees. You can only focus on the ticking bombs, the ones that if hackers actually use these exploits stemming from the vulnerabilities, can actually penetrate and run the vulnerable lines of code and hack into your systems. The other 80+%, you can patch later, you can apply different means, and you can take secondary measures. But reducing this number from hundreds to a dozen or 20 makes a lot of sense and is tangible. And going back to the analogy of gym, you don't have to get started with lifting your maximum weight and doing too many repetitions and working full body. You can start small, and then once you break your barriers and you can get into a regime, then you can work on the other muscles, work on the other things that will generate more power. But you need to get started with what really matters, and effective usage analysis is the best answer for that.
All right, so let's look at a couple of ways of doing that. Dynamic usage analysis sounds good in its name, dynamic, but it doesn't really serve quite the purpose that we're looking for here, right?
Yeah, well, dynamic usage analysis, or the equivalent of dynamic application security testing, is very good in the sense that it allows modern DevOps teams to automate those security tests by running certain workloads on a staging or a testing environment. They will never run in production, and see if a vulnerability can be reached. Usually you have automated tests that you can run and see if those automated tests will call the vulnerable lines of code. But the more important thing is to realize that you can never mimic all of the possible workloads on your application, even if you have the best test coverage in your systems. So you can have workloads that can never be repeated by your automated testing systems because they're unique or rare, or somebody can use them only once a while and you didn't think about it because they're not there. But you cannot, also you cannot tell if something is 100% safe, because you never know, the next type of workload that hackers can find to reach those vulnerable lines of code. So you can definitely say about some of the vulnerabilities that are effective because one of those workloads will hit those vulnerable lines of code, but you can never have a very good coverage in that regards.
Yeah, so it helps us maybe prioritize, but it can't help us ignore, because we can't know for sure that the code is unreachable.
That's correct. You can always know about part of the effective vulnerabilities. You cannot know about all of them, and you can definitely not know for sure that something is safe, which is how you save the actual developer hours and how you reduce this number to 20% or less.
Yeah, so we want to reduce that developer load by 80% automatically. So let's talk about static usage analysis.
So static usage analysis, although running in dev or staging environments, provides you with a much better coverage. It works on syntax trees, so it understands all the traces or all the execution paths that will ever reach the vulnerable lines of code, and it can tell you in almost 100% level of certainty what is definitely unreachable, because there's no way your application will ever call the vulnerable lines of code. It can tell you if something is definitely reachable, because there's at least one way of calling the vulnerable code from your application. It can By the way, it can also provide you with the forensics and the stack trace. So that also gives you a better way of addressing issues. You may want to bypass it. You may want to comment it out, just to resolve the vulnerabilities. So you also increase the number of ways you can remediate vulnerabilities. And sometimes it can, if something is unclear, it can, in very small numbers, it can say if something is maybe reachable. And then it's a secondary thing to address because you may want to take a secondary action.
Right.
But
So
it
the
is
key point here is that definitely unreachable category, right? Because that means definitely can ignore, definitely can reduce the workload.
Yeah, I mean, think about it as a traffic light. When there's a green light, you know for sure that you can drive. A red light, you don't want to you don't want to start driving, or and when there's a yellow light, you want to carefully think if you want to keep on driving or want to stop. So you need to make a judgment.
Okay, so this is a really effective way to reduce that volume of vulnerabilities in the business. We might say the false positives. And this is important for helping people not only get started, but also just in day to day in overcoming that volume. So like we said, decreasing vulnerabilities by 80%. Ultimately, effective usage analysis, it means that you've got, maybe 1/5 of the work that you would otherwise need to do, and that is done automatically.
Yeah. I mean, just adding into that, a lot of the times, we see developers going into the security teams who find a vulnerability in one of their transitively dependent package, and developers, they tell the security folks, we never use it. We don't even call this, these lines of code or these functions. Please, let us focus on what really matters. And these types of technologies can automate and reduce those, this friction.
Right. And we're talking psychology a little bit here too. And we've got some good points here. Like pointless work of any sort is demoralizing. So a development team that's asked by a security team to fix something that isn't like broken or isn't a risk is annoying. And importantly, it does lead to the boy who cries wolf one, where, if 4 out of 5 times the security team or the security software tells developers they've got a problem and they don't, well, that on those 1 out of 5, they're going to take it a lot less seriously, right?
Yeah, and just adding one number from the same survey you mentioned, developers spend 20 hours a month addressing security vulnerabilities by average. That's a lot of time. That's 2 whole days of work just for resolving security issues. And if you decrease that number by 80%, you have 16 hours more work to work on your business logic, to improve your business, which is a lot of time, a lot of development time, and definitely a lot of cost saving as well.
That's great. All right, so let's talk about then the second challenge and the second solution. So the second challenge is also the risk here. One of the reasons why it takes people so long to resolve vulnerabilities is because there is a risk in updating, especially if it is, a large update compared to what they have today. So how can we reduce or even de-risk these changes? I'll describe that now. So the solution to this in reducing risk is preventative health measures, which funnily enough is similar to physical health again. All right, so let's look at the benefits of being up to date with dependencies, back to what we talked earlier. So if you are literally up to date, then if there's a vulnerability fix available, by definition, you have it already. So that's a great benefit. Now, most vulnerability fixes will come to you in the form of a simple patch. It is general convention that when there is a vulnerability patch for a software, it doesn't come in like a huge big release. It should ideally come as a small patch that does the minimum work. So that is one of the the benefits of being up to date, is that the vulnerability fix then becomes something simple, that you can even review the code for. Another advantage of being up to date is that all bug fixes are applied. So, maybe some of those bug fixes that your libraries have fixed, maybe they even affected your end users even if you weren't aware of it yet. Like, it's not always easy on websites or software to realize when users are experiencing a bug that's caused by a third-party library. And then the final benefit is that, any new features are all available for any future code that you write. Right? So these are the benefits of being up to date. These are all the good parts. So let's be realistic, though. We talk about the risks. So one of the risks is new versions of dependencies can introduce regression errors. And by regression, I'm meaning specifically that something that used to work no longer works. I mean, if they introduce a new feature and it doesn't fully work, that doesn't matter because no one forced you to use the feature. But if they break an existing feature, that's what we call a regression error. And what that means is that the earliest adopters of new releases run the highest risk of hitting undiscovered regression errors. Because if something's broken, it'll probably be fixed. But, if you're using it right away, then you might be the person to discover it. So, can we prevent bugs in open source software? No. So that part is out of the question. There will be bugs. People are human. There'll be regression errors, like in any software. So then, can we better avoid broken dependency releases? And the answer to that one, though, is yes. So we can't avoid we can't avoid the existence of broken releases, but we might be able to avoid updating to them. And that's what we're going to talk about. So as an open source user, what do we really want from our dependencies? Well, we would like to be as up to date as possible while minimizing risk. Most people have no motivation to be out of date. That doesn't really benefit you. There's no benefits of that. It's only because of risk why you would stop being up to date. So if we can be as up to date as possible while minimizing the risk, then that would be a great thing. So in other words, the ideal scenario is to take every update possible unless it's a bad one, right? So one of the most valuable things we as an SCA vendor can do is to help you and end users avoid bad open source releases, and also to warn you about any breaking ones, whether they were properly documented or not. So with that capability, this is one of the missing links to having like safe and confident updates. So if we think then, how do we achieve this type of thing? So if we think about positive indicators about a new release, so a new release exists, what are the things that make us confident in it? So first of all, if there is the ability to have like a historical reliability or breakage ratio, that's one thing. So if you've been using a library for a long time and you use it across multiple projects, you may even yourself already have developed an understanding of which libraries don't break things generally and which ones do. And by the way, React is probably one of the best ones in the whole industry. They are very good with their testing before they release. As a second factor, the amount of source code changes. So if you have the ability to look and there's a new release and you see whether it's like, a one-line fix, like a typo, or whether, there's 17 files changed, that is also a reason whether to have, a positive indication or a negative indication. Because the more code that's been changed, the more likely there is that something broke, especially, the regression errors. If we keep going in terms of, factors to give you a positive indication, if the new release passes your test, that itself is obviously a positive indicator. Even better though, if this new release passed everybody else's tests as well, that would be a fantastic indicator. If somebody asks you to test if a wine is corked or a milk has gone sour, you can be fairly confident if you test it yourself. But, if there was a whole table of people already drinking it, you would kind of assume that it's probably not bad. And so that's similar. Like if something, passes not just your test, but everybody else's, that's an extremely good indication. All right, so continuing with our levels of confidence. So if a significant proportion of other projects have already upgraded to the new release, that's also another reason to have confidence in it. We looked before that, 76% of projects were on React's latest release, 41% were on ESLints. Both of those are very positive figures, so if you were looking at that release right today and you could see what percent of projects had already updated, that would give you a high confidence in that release. And then the final factor, which is a really strong indicator, positive or negative, is whether projects have rolled back. So, you know, if you could know that projects have updated to this new version and then gone back to the existing version, that itself would be a very negative indicator. But if these projects had been running it and essentially nobody had rolled back, then that would be a positive indicator. So these are all ways that these are kind of factors that we can use to build up confidence in new releases. And
This,
yes, David.
again, to the analogy of working out and going to the gym. So if you see most of your friends working out, looking better, going to the gym, you'll probably end up going to the gym yourself.
That's
Kind
true.
of the same thing.
Yeah, yeah. You are the average of your 5 best friends or something like that.
That's right. Yeah.
So, well, yeah, we're going to talk about crowds here. So, look, the most important indicators on that previous slide you saw, they actually came from aggregate data. So, you know, your own test results was kind of number 2, but, you know, looking at everybody else's test results was number 3. You know, so even the largest of enterprises, the largest customers, they may not have enough diversity in their use of packages to be confident that nothing changed and nothing broke. So just like real life, diversity is very useful, right? So only a diverse sampling of test and deployment results across the industry can be used to really like rapidly detect problems in open source. And this is what we call like the power of crowds. And this is something new because until now, people have always based, you know, their confidence in a release on, you know, has it broken things before? And, you know, did it pass my tests? And maybe I manually tested it if I have QA. But this is all limited. You still have like a doubt. Whereas if you multiply that by the size of the industry, you know, the number of people who are also testing and reviewing, that gives you an extremely high confidence factor compared to just trying to decide things on your own. And that's what we're trying to bring. So a tool I mentioned before, WhiteSourceRenovate, its purpose is to automate updating of dependencies, whether they are vulnerable or not. So this is about your general dependency health. And the strength of WhiteSourceRenovate comes from its size and what it does. So it's a hosted application for github.com and gitlab.com. It's been installed in over 150,000 repositories. It's run over 200 million jobs on those repositories, and it's created over 1 million pull requests. So this is starting to get to a scale where we can build up extremely good confidence in releases based upon the aggregate data that we see. David, I don't know if you've ever seen, sometimes people have done very creative stuff with Google search trends, where, for example, if you see people searching for fever or runny nose, it can be used as a predictor about like outbreaks during flu season. It's a similar kind of concept here where, you know, by taking like a large sampling of users or people, you can derive very interesting conclusions from it without caring or looking at the individuals within that sample set. So WhiteSourceRenovate runs continuously to monitor dependency versions and automatically propose updates into installed repositories. So we are using this to build up a picture about who is using what dependency, who has got a pull request for a new version, and also the aggregate test results for those new versions. Okay, so one thing though is important is that not all data is created equal. If we look here quickly at apps versus libraries and public versus private, if you think of libraries like open source libraries, in a way, they normally stay up to date with dependencies automatically because they just use open ranges. So the purpose of the library is to be as compatible as possible. So they typically just say, well, any version, you know, 1.x or 2.x will do. And they're not actually like testing every version. They're passing on that risk of new releases to the downstream applications. So it's not really the purpose of library authors to test every single new release and add exclude rules if one of them, you know, was shown to be like a broken release. Now, the problem is that most public repositories, you know, like on github.com or gitlab.com, you know, if you're thinking about scanning public data, the problem is most of them are either libraries, like open source libraries, or they're, you know, non-production applications. They're like people's test repositories and things like that. So neither of these is a very good measure of whether a new dependency version is good, because neither libraries nor non-production applications are really putting a lot of kind of effort into verifying whether new releases are good. So therefore, the most powerful data it actually comes from active private repositories with strong test suites. All right, so WhiteSource's dependency vision based upon that is that we will provide users with a confidence in open source releases that they could never obtain on their own. And this is a key part of that, the power of crowds. We want to allow projects to define tolerable risk levels for adopting new releases, because not everybody has the same type of approach. You know, a startup in a rapid development mode will want to take releases much more earlier than, you know, a legacy application that is in maintenance mode. So tolerable risk levels per project. We will utilize the power of Renovate's data to reliably determine the risk of new releases. Deliver regular bundles of updates that just work, allowing companies to stay reasonably up to date and also ready to respond quickly when needed. And this is a key part of the automation, because today we're at a point where, you know, we're automating the updates pretty well, but we're not quite at the point of just work yet. So that's really the key to making it simple for people to get that dependency health. And then the final point, apart from, you know, using crowd data to assess the reliability of new releases, is we want to apply our industry-leading vulnerability detection plus effective usage analysis to alert users whenever a new release should be verified and applied out of cycle. So, you know, if there's a critical patch, you know, critical vulnerability patch to a production dependency, you're going to want to know about that right away and not wait until, you know, everybody's finished testing it and deciding if it's okay. So this is what we believe is like the key to people, you know, getting in health and staying in health when it comes to their dependency use. So now, David, back to you.
Thanks, Rhys. So kind of summing up this session, and again to the analogy of like physical health, you just need to get started. You don't need to be afraid of consequences. And you know, you need a little bit more than just awareness and availability of tools to be successful. You just need to change your mindset. Once you do that, you'll be able to keep up. You'll be able to keep in shape. You'll be able to have a healthy dependency situation, and use those tools or processes to make it better, to automate it, to shift left, to remove frictions and remove noise, and you know, see the forest from the trees. There's a lot of good practices we mentioned during this session. Definitely using things like effective usage analysis, using the wisdom of the crowds to understand dependency merge health, and looking at you know, learning from others. And you know, I would say that the secrets for adopting safe open source is kind of twofold. First of all, you know, it should just work. Try to automate as much as you can, and there's all these tools out there. Try to do that with the minimum effort. You'll both gain valuable development time, but also you'll gain a lot of cooperation from the development teams and reduce the risks because you focus on less issues you need to remediate. And then do the manual remediation, detection only when you really need it. So try to limit it and make it justifiable, not to put a lot of load on your development teams, and making it easier on them to cooperate with you in the future. So Rhys, thank you very much for this enjoyable session. And this is the time for the audience's questions and answers.
All right. Well, we are now going to go into the question and answer period. So if you have a question for either of our speakers, actually for David, please go ahead and use your GoToWebinar control panel. We've gotten a couple in so far, so let's go ahead and get right to them. Let's see. Here's our first one here. Let's see. Okay, how do I know that keeping my dependencies always up to date will not break my application?
Yeah, that's very interesting. You have to find automated ways of testing those fixes and understanding the impact on your existing applications. So what you need to do is you need to look at the changes between the vulnerable version and the fixed version and see if your application is really calling this code. By using technologies such as effective usage analysis, you can automate the whole process um, and try to minimize the efforts to detect those and be as up to date as you can. So this is just one way of automating it, but if you cannot automate it, try to manually understand that. And there's always the question of the balance between the business impact and the risk associated with running with a known vulnerability that you need to take. And again, once you automate it, when you keep it down to a minimum time to analyze it, you'll be back in shape as fast as you can.
All right, great. Let's see, next question here. Do you believe a demand for proprietary operating systems and or software will become a reality given the current overflow of black hat hackers? Don't recall a VAX VMS system ever getting hacked. If your answer is no, then what would you tell administrators to do when a known open source vulnerability is active? Should the system be shut down until the vulnerability is fixed and does not break something else? That's a long question.
Yeah, let's start with the end. I mean, I kind of answered it in the last one. It's a balance between the business impact of the system and the vulnerability severity and effectiveness. So if you know that this vulnerability is already exploitable and it's of a high severity and you know that it's actually effective. So the way your application is consuming the open source code will actually call the vulnerable lines of code. Then you need to weigh between an outage of the app for patching it, for a few minutes, hours, and so on, or run it for a while taking the risk of the system being hacked. Um, I would say that if you apply many of these automated tools and if you keep your dependencies in shape and try to keep up to date, you'll prevent more than 90% of those cases. But if you're up to those 10%, then you need to take a business decision at that point. And I do think that we'll see, I wouldn't say operating systems, but we'll see, with cloud native, we'll see hardened Dockerized versions of software where you kind of remove the traces of what constructs those images. So, try to limit hackers and in a way that they will not understand what type of packages or languages were involved creating those Docker images. That's kind of the modern way of hardening your software. And we see a lot of customers trying to do that and remove those traces so hackers will not know how to attack those systems because they don't know what they're comprised of.
All right, great. So we're about 6 minutes to the top of the hour. I think we can do one more question here, maybe two. If my application is bound to a closed network where it doesn't have internet-enabled access from an application server, do we still need to prioritize and do large changes of fixing vulnerabilities?
The answer is definitely yes. First of all, there's always the risk of an insider attack. Although it may be a little less riskier than hackers from the outside, but we know of very famous attacks of people from the inside who penetrated into systems and stole data or committed fraudulent activities. And the more complicated answer is that if you don't keep your dependencies in shape, it will be harder and harder for you to do that if you do that once a year or once in every 2 years, because at that point it will be really hard to jump, I don't know, 3, 4, 5 versions up without breaking your application. So at the point you'll find one of those vulnerabilities, it will be much harder for you. So our recommendation is to always be on the latest or the closest to the latest version. So when you need to update those systems, it will have a less of an impact. And it will happen faster.
All right, great. Let's do one more question, then we'll go ahead and close out the question and answer period. Can you keep your Docker files dependencies always up to date?
Yeah, that's a very interesting question. And modern systems comprise their the way they ship software using Docker images, and the way they construct those images is by declaring the pieces of software, the packages in a Docker file. And the answer is yes, Docker files can also be scanned for the components or the open source packages that are installed in them, and can also be automatically remediated by taking those dependencies to the next level, to the next version. So definitely a Docker file is something that you should and need to keep track on, and also try to use the latest versions of software, again, to reduce the risk and to keep in shape.
All right, great. Well, we are about 4 minutes to the top of the hour. So unfortunately, actually 3 minutes to the top of the hour. So unfortunately, that's all we have for the question and answer period for today. If we didn't get to your question, I apologize, but please know that the folks at WhiteSource will be getting a copy of all the questions, and I'm sure somebody from the organization will be more than happy to follow up with you and get your question answered. Also want to remind the audience that today's event has been recorded, so if you missed any or all of it, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars and look in the on-demand section. It should be right there waiting for you. Okay, at the top of the hour, I did note that we would be doing a drawing for 4 $25 Amazon gift cards. So let's go ahead and do that real quick. Our winners today are Rick T. Congratulations, Rick. Scott M. Congratulations, Scott. Don M. Congratulations, Don. And Dave A. Congratulations, Dave. Check your inbox, guys. We'll be sending you an email regarding the Amazon gift card, and if you don't see it in your inbox, please check your spam folder. Dave and Rhys, thank you so much for such a great presentation. As always, you guys provide such fascinating webinars and such interesting conversations. So do thank you for your time and for your expertise. And I also want to thank the audience today for joining me. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Please stay safe.